Of the gases reveals that they are a mix of carbon dioxide, sulfur dioxide, and hydrogen sulfide. It is the same mix that is found coming out of volcanoes. But the final clue to what's actually going on underground is found on the edge of the same hot springs.
So these are quartz crystals that we collected on the side of the pool there. This stuff is what remains. It gets tossed up. It forms a little berm around the side of the pool. And it's all beautiful little quartz crystals. Some of them have a little bit of iron staining and other things, but most of them are nice shades of yellow and clear.
Quartz crystals like these can only have formed as a hot molten rock lava flow slowly cooled after being erupted onto the surface from deep underground. So the crystals are clear evidence that under the springs is a volcano. Yellowstone's hot water features all point to one conclusion. Yellowstone must be powered by the heat of a volcano. Geysers only erupt if the rocks are hot enough to turn water into steam. Gases from underwater have the same composition as those from volcanoes. Quartz in the hot springs must have come from volcanic lava.
There is an immense amount of energy coming out of the ground that's expressed by the geysers, the mud pots, the hot springs, and the steam vents. Where's all that heat coming from? It's coming from the molten rock associated with the Yellowstone volcano.
But that leaves a big question unanswered. In this gentle rolling landscape, where's the volcano? Yellowstone's unique volcanic geology is potentially deadly dangerous. It makes it crucial to monitor what's happening under the ground.
The Yellowstone volcano is a very, very active volcanic system, and so it really requires observation. Everything that we do here has a research component, but it also has a volcano monitoring component. And you know, if activity picks up here, we're going to want to know something about the plumbing system beneath us here.
To try and predict when Yellowstone's hidden volcano will erupt in the future, scientists study its geological past.
Part of our task is to look at the landscape and read the geologic story. And there's so many clues and so much evidence here to look at that it's a fascinating place to work.
Scientists began investigating Yellowstone even before it became the world's first national park in 1872. But observations of this astonishing land began long before that. Dating ancient arrowheads shows that Native Americans first lived here 11,000 years ago. Their legends of Yellowstone's angry spirits who made the ground tremble were passed on to early explorers such as Lewis and Clark. Later reports from trappers, explorers, and mountain men like John Coulter and Jim Bridger told of geysers that fired 70 feet into the air and springs so hot that meat was readily cooked in them. But these were thought to be tall tales until the 1860s, when geologists investigated and found that the lava flows and hot vents were signs of volcanic activity. But something clearly wasn't right. Nobody could actually find the Yellowstone volcano.
We say that Yellowstone is one of the world's most active volcanoes. People come out here, visitors, other scientists, and they say, "What do you mean? I don't see a smoking volcano. I don't see a big, steep volcanic crater," all the things that one normally thinks of for an active volcano.
So without obvious signs of a volcano, scientists hunted for other clues. They would find them in the sweeping forests of lodgepole pines. These are the only plants that thrive on the poor soil that comes from a particular type of lava called rhyolite. And Yellowstone's constant plagues of mosquitoes also reveal the presence of that same rhyolite lava.
The rhyolites are not very permeable, and so it creates these little ponds of water that never go away. And those are wonderful breeding grounds for mosquitoes. There are a lot of mosquitoes, if you can't see them, flying around my head.
So the pine trees and the insects both indicate that there's a lot of rhyolite in Yellowstone. And that's important, because rhyolite lava creates incredibly violent volcanic eruptions.
It's much more like a bread dough. It's about 1,000 to 1,000,000 times thicker or more viscous. We put a bunch of gas in it, we can have a very explosive eruption.
But if rhyolite lava is that explosive, how big a bang did it produce? To find that out, scientists looked not inside Yellowstone Park, but in a faraway river valley at Meadow Creek, Wyoming. Cutting down through the land over millions of years, the river has exposed an unusual thin layer of black rock in the cliff face. A nearby road cutting lets investigators examine the mysterious dark rock.
If you look at this sample in detail up close, you can see that here's a pumice fragment. These red fragments here are little rock fragments. And if we were to make a thin section of this rock and look at it under the microscope, you would in fact see compressed glass shards.
The black layer that geologists call obsidian is actually a type of glass. It's crucial evidence that the rocks and soil here came out of a volcano. Because obsidian is forged when boiling hot ash and gas rapidly cool under great pressure. And that's just what happens when hot volcanic clouds roll out across the landscape. The obsidian forms in the very bottom layers, cooled from below and crushed by the weight of hot debris on top. The ash layer that crushed the obsidian at Meadow Creek is still visible today.
Its base is characterized by this very thick, dense obsidian as the flow came to rest and was compacted. And then above this dense glass layer it grades upwards into a tan sort of region and continues up for about an additional 30 feet. And then up on top of that, as it's exposed today, a modern soil has formed, and we can see growing up there various sorts of vegetation, trees and grasses and things of that sort.
Studying the mineral composition of the ash proved that it came from an ancient volcanic blast in Yellowstone Park. And there's only one way that so much ash could have been blasted so very far away from its source. The eruption must have been larger, far larger than anything ever seen by man. So big that scientists now label it as a super eruption.